Here, tick include UVM macros SVH. This is same. Import UVM package, same. Class comp, this is component. Extends UVM component. All components must and should. We need to factory registration should happen. This is called factory registration. Tick UVM component utils comp. Function new. In this, two arguments will come definitely. In object, only one argument will come. Here, two arguments will come. String function, string path equal to comp. Same class name. The string path equal to UVM component parent equal to null. That parent is equal to null. Super dot new path comma parent end function. Virtual function void build phase. See here, there are certain 20 phases are there. Okay, among them most important phases is build phase. Next is connect phase. Next is run phase. I mean a little bit end of elaboration phase. See, these phases are very, very important. In run phases also, there are so many phases. Okay. So, uh, build phase means it will build it will build the environment. Run phase means it will run. Connect phase means it will give connection from one port to another port. That's
एक
it.
सेकंड एक सेकंड
What?
हो गया है हाँ धनुष कैरी ऑन
Build phase. Super dot build phase. Okay, we are giving argument as phase. TQM info comp build phase of the comp. This is a class name. Executed. Verbose is UVM none. This is 0. End function class. So module TB. We are coming to module TB. Comp C handle we are creating. Initial begin C equal to comp type ID create. Here we are creating a memory. C command null pointing to the UVM root. C dot build phase null end module. Okay, this is how we will run this. And in this, what do we will expect? What we will get? See, build phase comp executed. If there is a code, it will execute that code. It is a display statement. It is executed. Okay. Tick include UVM macros dot svh same. UVM import package colon star same. Class A extend UVM component. Class A class name is A only. Tick UVM component utils A. Function new string path equal to A. UVM component parent equal to null. Super dot new path comma parent end function. Virtual function void build phase. UVM phase. Super dot build dot build phase. Tick UVM info A uh, class class A executed UVM none end function. Class B extends UVM component. Tick UVM component utils B. Function new. String path B. UVM component uh, parent equal to null. Super dot new equal to path parent end function. Virtual function void build phase UVM phase UVM super dot build phase. See, here we need to give argument as phase. Same thing here compared to virtual function and normal function, there is nothing. The word virtual is there. Okay, that's it. So the function can be implemented in further sections, not in the same section. Okay, UVM phase tick UVM info. A class be executed UVM none end function. Class C extends UVM component. Tick UVM component utils C. A instantiation, B instantiation. Function new string path C. UVM component parent null. Super dot A equal to path comma parent. Here it is a component, so obviously you will get two arguments. String path A equal to C class name, UVM component parent null. This will point to the UVM root. Super dot new path parent end function. Virtual function void build phase UVM phase. Super dot build phase. A instantiation A relaxation operator. Type ID relaxation operator. Create equal to A instant this. B instant B relaxation operator. Type ID relaxation. Create B instance B. Virtual function C. Virtual function void means don't return anything. You are telling the function to not to return anything. End of elaboration phase UVM phase super dot end of elaboration phase UVM underscore top dot print topology end function end class. See, module TB initial begin run test C run end module. Okay, we will see this. UVM N4 5 warning 0 error 0 fatal 0. Okay, report counts by ID. This is same. Tick UVM macros.svh is same. Import UVM package colon star hash also same. Class environment extends UVM environment. Tick UVM component utils environment. Int data. How many bits do int will take? Neha? Int variable means how many bits it will take?
Bits it will take.
Hmm?
I can't make out right now.
32-bit. This function C, function new, string path equal to class name env, UVM component parent null, two two arguments, super dot new path comma parent end function. Virtual function void build phase, UVM phase, super dot build phase equal to build phase. If UVM config db, this is config db. There is one concept called config db, configuration db. Okay, that I'll explain later. Okay, as of now, config db hash int scope resolution operator get null UVM test underscore top data data tick UVM info env equal to $s format of f value of data equal to percentage 0d data UVM none else tick UVM error env unable to access the value end function see class test example UVM text tick UVM component util test in the test we will instantiate environment, right? Env equal to e class function string path test equal to UVM component parent equal to null super dot new equal to path comma parent end function virtual function void build phase UVM phase super dot build super dot build phase e equal to env type id create e dot uh, this function UVM config db instantiate set null UVM test top data 12 context end function module initial begin run test. See, we will see this. See, UVM info 3, UVM warning, UVM error, UVM fatal, 3 displays UVM. See, the displays are running test, UVM top, UVM value 12, reporter, sorry, wait. Sorry for the disturbance. Actually, design we'll see. Design actually 4-bit adder, 4-bit general purpose adder. Okay, 4 full adders it requires. Right, to add 4-bit number it requires. Here 5-bit we taken for example, if a carry arises, that carry should hold in a fifth bit. That's why this is 5-bit. As this is which model it is. Okay, you don't know design, right? Not a problem. This is your data flow model. Okay, y equal to a plus b. This is a adder. Interface logic adder if equal to logic 3 down to 0 a, 3 down to 0 b, 4 down to 0 y. Okay, this is my design. I want to check this design whether it is working fine or not. For that, what I'll do, simple, I'll go to verification tb. These are same, I told you, right? For all the codes we need to write these two statements without fail. Okay, first thing is a driver class. Drv extends UVM driver. Okay, tick UVM component. This is a component utils drv class name. Virtual adder if equal to AIF. This is virtual handle, virtual interface handle. Function new equal to this is a component, right? So two arguments will come. Two arguments. One argument is input string path drv class name. UVM component parent equal to null. This is same, super dot new path comma parent, that you will give, end function. Virtual function void build phase, UVM phase, super dot build phase. If negation of UVM config db, see virtual adder if get this AIF. Okay, this is for example negated. Okay, if it doesn't happen at that time, what it's supposed to do? Negation means if it doesn't happen, it's like a else. Tick UVM error, DRV unable to access the interface. Driver should be able to access the interface. It has to drive its data packet to the pin level information of interface through DUT. It has to forcibly a- send the signals. Unable to access the interface. Where is it? Get AF, UM test stop, agent DRV, and virtual task run phase. UVM run phase. Okay, this is task. Phase dot rise objection this for int I equal to 0, I is less than 10, I plus plus. Begin AIF dot A, which means this is to DUT. Directly, it will connect to the DUT. A interface will directly connect to the DUT. For that A, we are giving at the rate dollar u random. That u random function we are giving it. Are you getting?
Yes.
So for that
Hello.
for that B pin also u random function is giving after 10 nanoseconds. Okay, this sends. Okay, phase drop. Here phase dot rise dot objection this. Phase dot drop underscore objection this. These two should be, we should write for synchronization. Okay, which means we are telling it to the UVM, stating that here my phase is rising. Okay, here my phase is dropping. Once this randomization is done, how many random votes will be given?
0 to 9.
Very good. That's it. End class. After that, class agent extends UVM agent. Okay, tick UVM component utils agent. This is also component UVM agent. Function new input equal to string instant equal to agent. UVM component C two arguments. Okay. For that instant comma C instant instant comma C we are getting end function DRV in agent driver handle we are creating virtual function void build phase UVM phase super dot build phase D equal to DRV type ID create DRV this end function. This is also end class. Okay. UVM environment extends UVM environment. Okay. Class environment extends uh, tick UVM factory registration must be done for every class. So even for objects also you do factory registration so that you will habituate it. See, you will feel like wherever there is a there is a class is coming, so I need to do for factory registration. So it's a better choice. For objects, you can do it or you can't do it. It's not mandatory, but for a component, it is mandatory. You have to do it. So better have a habituated that whenever there is a class, better to register in factory. Tick UVM component utils env function new. This is a component. So two arguments will be there. Input string instant equal to env UVM component C super dot new equal to instant C end function agent A virtual function void build phase end uh, end UVM phase super dot build phase A equal to agent colon type ID resolution create agent this. Next test. Actually in SV where we will randomize in which class? Neha, I am asking you.
Yes.
In which class we will randomize inputs? In which class we will randomize in inputs in system Verilog
I forgot.
generator class. Now here we
Okay.
are making in a driver class so that we are avoiding writing generator class. Directly we are going for a driver class. There we are writing. See function new input string instant test UVM component C super dot new equal to instant comma C end function environment E virtual function void equal to build phase UVM phase super dot build phase equal to phase E dot env type ID create now env this class. See now we will came to module. See first adder if equal to AIF. Okay, this is virtual interface handle we are creating. Add a dut a dot aaf dot a b dot aaf dot b dot y aaf dot y initial begin UVM config db. Okay, hash virtual add if uh, scope resolution operator, set null, UVM test, UVM test top, env.agent.drv, okay, af.af, test run, test, end, initial begin, dump file equal to dump vcd, dump vars, dump file, dump vars are for creating waveforms, okay, end module, end. Okay, we will see. Class will end in 10 minutes, okay? We will connect after lunch.
Okay, okay. At 2 p.m. let's connect at 2, है ना? Right.
Yeah, yeah. Where is that? Oh, I didn't tick this. I didn't tick this. But still, let's see. Where there is random values should come, right? 10 random values. Where there is coming? Where is the random values are coming? Why random values are not coming? Random values are not coming. I don't know why. Here coming. There in log file it
Okay.
is not coming. I don't know why. Like this in log file also should come, right? Neha?
Right, right.
3, 4, 17, 6, 9, 15, 9, 11, 9, 11, 20. Okay? Are you okay
Okay,
this?
okay,
Now, what you will do is you go through uh, basics of this UVM in verificationguide.com.
okay,
No, you don't go through now. You go for lunch. Take some rest.
okay,
We'll start at 2
okay,
o'clock, 1 hour after 1 hour. We will finish these things. Okay?
okay,
After that, we'll take a pen and paper and execute it. Everything you will execute and try to understand. Okay? You are too sharp. You can grasp very fast. Not a problem. Okay?
okay.
Okay, bye.
Right.